All right, good morning, class, and welcome to class. Today I'm going to start off with an icebreaker, as I always do. So today's question is, what is your favorite shape and why? And I know you guys all have this in the back of your mind, just like your favorite color, you got it. Yeah. Triangle, because your favorite number is 3. Makes sense. Oh, you like rectangles because rectangles are the shape of boxes which have food in them. Way to connect that to our previous lesson. Yeah, well, mine is circles because in math you can do like so many, like a bajillion different things with circles. There's so much. You guys are in for a treat when you're taking math. All right, so let's start with today's lesson. We are working with right triangles. So excuse me if I accidentally call it a rectangle because sometimes I do that, but I'm talking about triangles. So, looking at this right triangle, do any of you guys know the side lengths? That is a good guess, but no, I don't even know what they are right now. So yeah, we can't tell from just looking at this picture without like measuring it or whatever what the lengths of the sides are. So, I'm going to help you guys out a little bit, but after I give you just a little tiny lesson on some vocabulary. So you see this little square? Do you know what that means? Good. It means it's a right triangle. And a right triangle is a triangle that has a 90-degree angle within it. So we're going to be working with only right triangles for like the next 3 or 4 days. So another term I want you guys to know is what this long side length across from the right triangle is called. That's called the hypotenuse. And I don't know, it's a long word, so I guess the way you can think of it is like hypotenuse. I don't know, that might help you. So these shorter lengths are called legs, and they're always going to be attached to the right angle. And the longer one is always going to be across from the right angle, and that's the hypotenuse. So these don't really have special names, just like adjacent or legs or whatever. But the hypotenuse has got a special name, and it's always going to be the longest, no matter what. Okay? So now that you know that terminology, we're going to try to figure out the side lengths of this right triangle. I'm going to help you out a little bit. I've got some squares, which is fun. All right. Okay. So these squares are going to help us figure out the side lengths. Alright, so looking at these squares, does anyone have a clue on how we're going to use the squares to figure out side lengths? Yeah, so it has to do with the area of the square for sure. So using the area of, let's just look at this square right now. Using the area of this square, can we figure out what this side length is going to be? Anyone? What if we used the formula of the area of the square to figure out the side lengths of the squares? Can we do that? Yes, because the area of the square is equal to s squared, or side squared. So we just have to take the square root of 9 right there, and that'll help us figure out what the side length is. So the square root of 9, Jim. Yes, 3. Good. So I'm going to write that down. So this is equal to 3 inches, and I'm going to put it over here because I can't really fit it right there, but this side length is the same as this one is that one because it's a square. So this side length is going to be 3 inches. So can we do the same with this one? Yeah, 4. Good. You guys are already catching on. Great job. All right, 4 inches right here. And don't forget your units. It's very important. All right, now what's this one? Come on, you guys know this. Oh wait, there's no area written there. How can we solve for that side length? I don't know. Just kidding, I do. So we don't have all the information right now to figure that out, but I can tell you how we can figure that out. I'm going to give you a little connecting piece of information. So the area of this square right here plus the area of this square is going to give you the area of this square. So it's not going to give you the side length, but it's going to give you the area. So what is the area of this square? Good, 25 inches squared, because 16 plus 9 is 25. So I'm going to write that right here. And I'm going to put inches squared so you don't confuse it with a side length. So make sure I'm going to put a square around, or a rectangle. Okay, well, a shape around it. That's bad. Okay, so the area of this is 25 inches squared. So what's the side length going to be? Good, 5. So 5 inches. So I want you to notice that the areas 16 and 9 give you 25, but the side lengths, 4 plus 3, do not give you 5. They give you 7. So you have to keep that in mind. There's no like shortcut. You can't say, oh, 4 plus 3, so this side length is going to give you 7. I wish it was that easy, but also I'm glad it's not, because it's more fun and more challenging to do it this way. All right, so we're gonna do another problem, and then you guys are gonna figure out a formula, and I'll tell you the name of that formula on the next problem. So let me get these squares down. And the cute little square. Alright, so this, I don't know if you can tell, but that forms a triangle. It's the negative space right there. Okay, so we've got our areas again. So let's just zoom right through this. What is the side length going to be of this square with an area of 1? Good, 1 inch. Alright. And this side length right here, whoop, oh no, stay, okay, no, stay. Okay, so the area of this square is 4 inches squared. So what's the side length going to be? Good, Rob. It's going to be 2 inches. All right, so now the side length is just 3, right? No. Miss Evans, what are you talking about? It's not going to be 3. You can't just add those side lengths. This area is this area plus that area. Then you find the square root to find that side length. So what's the area of this square? Good, Sally. It's 5 inches squared. And let me put a shape around that so we know it's not the side length. All right, so now what's the side length? What's the square root of 5? We don't know. So I'm going to make this easy on you guys so you don't have to punch in your calculator. We're just going to leave the answer really nice and clean, and we're going to leave it as radical 5. Radical 5 inches is going to be this side length right here. And these are like to scale, just so you all know. So this is radical 5 inches. So now, is there a formula we can figure out from all this? Anyone have any ideas? Okay, let me add something to this. Maybe it'll help. I'm going to erase all of our hard work. And I'm going to assign variables to each of the side lengths. So let's call this one A, and this one B, and then we're going to call the side length of the hypotenuse C. So how can we come up with a formula to find C, or C squared? Let's go C squared, because C is like all over the place. So to find C squared. Yeah. Yes. So what did I tell you before? So this area plus this area equals that area, and that's how we've been finding all the side lengths. So what's the area of this in terms of A? Good, A squared, and then, yep, plus B squared, and that is equal to C squared. And that is our beautiful formula, and that is called the Pythagorean theorem. And I might be butchering the name a little bit, but that's what it's called. And it's a really cool theorem, and you'll be using it so much in all your math, and it's probably my favorite theorem in the world. All right, so with that in mind, we're gonna go on to the next problem, okay? Let me erase all this. And so just like we assigned C to the hypotenuse, C will always be the hypotenuse. A and B you can use interchangeably, whichever leg you want to be A, whichever leg you want to be B. So let's move on to the final problem. Okay, two things are kind of weird about this one. So this one, I don't have areas listed. I instead have side lengths. And then also, where's the hypotenuse? Yeah, it's right there. That's the longest side length. That's how you know I didn't put in my little square. But there it is. And that's across from the square. So the hypotenuse has a value right now. And it's all side lengths. So that's a little tricky. So what we're going to do is first assign variables to each of the side lengths, and then we're going to plug in our numbers and see what we get. Okay, so Joe, what do you want this one to be? A. Good. Good that you didn't use C. Joe, can you tell me which one would be C? Good, the hypotenuse. C is always the hypotenuse. So we'll leave this one for B. Okay, so A is the side length, right? So what will we put first? We won't put 4 squared. That is 4 squared is 2 squared. A is 2, so we're gonna put 2 squared. And then plus, we don't know B yet, so we're just gonna leave it as B squared. And that equals C squared. So what's C? C is radical 13, so radical 13 squared. All right, now let's solve what's 2 squared. Good, 4. And then plus B squared. And that equals, yes, what is radical 13 squared? Good. Joe, 13. All right, so now you guys know your algebra, so let's subtract 4 from both sides to find B. It's B squared. So B squared, well, I'm running out of room. B squared equals, what's 13 minus 4? Good, 9. That was quick thinking. All right, and then to find B, what should we do? What can we do to both sides to get B all by itself? Yeah, take the square root. Very good. That was kind of tricky. So take the square root of both sides. And so we've got, I'm going to write up here, B equals, what's radical 9? 3. Good, Mike. Equals 3 inches. And that is how you use the converse. So you guys are a step ahead just using the Pythagorean theorem. You just use the converse. Usually I will give you the side lengths of the legs, and then you have to find C, which is a lot easier. So I made you do the hard way. Sorry, guys. So yeah, great job. Now we're going to move on to some guided practice. What I'm going to have you do is, I made 15 of these bags, and in each bag is 2 squares. And one of the squares is the hypotenuse, or one of the lengths. One of the squares, the length of the square is the hypotenuse, and the other is the leg. Now, which one do you think is going to be the hypotenuse? Yes, the longer one. So proud of you guys. All right, and then I have 15 other squares on the table over there. And so your job is to measure the lengths of these sides and then use the Pythagorean theorem to figure out what the missing side length is going to be. So you can either do it that way, or you can set this up and then try to grab some squares from the table and make it so that you can make a right triangle. You have to be careful about that though, because even if it looks super close to a right triangle, it might not be. It might not be a right triangle, so you have to still use the Pythagorean theorem to check your work. And then another thing I wanted you guys to remember was, what else did I want you guys to remember? Well, okay, I'll just explain independent practice. So after you're done with that, you guys will each grab one of the pieces of colored paper over there, and then use a ruler and make your own right triangles. And doing that, I want you to start out with 2 of the triangles start out with a hypotenuse and a leg, and then the other 2 triangles, 2 legs, start out with legs, and then find the hypotenuse. And then, so you'll have a total of 4 triangles you're supposed to make. And once again, just be careful, because like you can't just come up with 3 side lengths and that's a right triangle, because, like, for example, these don't match up to make a right triangle. These 3 side lengths, look, it's gonna be it looks like a scalene triangle, and there's no, well, right triangles are often scalene, so ignore that part. But this looks like an acute triangle. Obtuse? Obtuse. Oh boy, I have to brush up on my math. So yeah, so this isn't a right triangle. So you have to really use a Pythagorean theorem, and that's always going to be a great way to check your work to make sure it's a right triangle. And other than that, you guys are good to go. Raise your hand if you have any questions. Good talk.